It's good to see you again. Welcome to the online class. Uh, so we are actually discussing interfacing of your IO devices. So how to interface different input and output devices to your 8051 microcontroller. And so far we have seen how to interface 7-segment display, which is output device. And we have seen in the last video like how to interface matrix keypad. So 4x4 matrix keypad. Okay. So today we are going to learn about interfacing of 16 by 2 LCD. So LCD in the sense liquid crystal display. So someone will call it as a 2x16 or 16 x 2. So 16 by 2 LCD, which we are going to learn about how to interface this display to your 8051 microcontroller. Okay. Now you tell me, what is this device? Is it input device or output device first? So which is output device? Why? Because this is display. So just like your monitor. So whenever if you want to see some information in any display, okay, that is called your output device, right? So how you will interface generally monitor to your computer, like your CPU. So you will use some cables, right? Similarly, here we are going to use some cables in order to interface this 16 by 2 LCD. Okay. Now in the, if you pay attention to the last classes, we have seen the 7-segment display, which you are going to which you are seeing in the left side of this picture, right? So this is the 7-segment display. In this 7-segment display there are 7 LEDs. So each and every LED will be controlled with the help of one pin, okay, which is having in your 7-segment display. According to that, you can able to display some information. But contrast to that, we are having 16 x 2 LCD. That means 16 by 2 LCD, which in the sense here we can able to display total 32 characters. So 32 character means either alphabets from A to Z and the numbers from 0 to 9, etc. So and also you can display some special characters also. Okay. So this is the advantage of the 16 by 2 LCD apart from your 7-segment display. So in this 16 by 2 LCD, we can able to display more information. Okay. Not only in one digit, we can able to display multiple digits or multiple characters, special characters, and we can able to display some small animation graphs, etc. in this 16 by 2 LCD, right? And this 16 by 2 LCD will has inbuilt controller, which is called liquid crystal controller unit. So this is the backside part of the 16 by 2 LCD, okay, where you can able to see there are some black color dots, so big dots. So this is called insulation, and this insulation, inside this insulation we are having, sorry, so inside this insulation we are having controller in it. So it is where this controller can able to inbuilt controlling the LCD. Okay. Now why we can again we require 8051 microcontroller. So 8051 microcontroller is required to send the commands to the display, and it and 8051 microcontroller is it to send the data to the display. Okay, first you will send the commands, later we will send the data. So depends upon the commands received by this liquid crystal display, the controller in it will able to display the data which is sent by your 8051 microcontroller according to your command. Okay. So this is the need of the controller in this 16 by 2 LCD. Okay. And we are going to see what is 16 different pins available in the 16 by 2 LCD. So what is exactly 16 by 2 LCD means? You can able to see in the previous slide. Okay. Can you able to observe the shaded background for each and every character? So for T there is a shaded background. Okay. So generally these are nothing but rows. Okay. So the 16 by 2 LCD is divided into rows and columns. So how many rows we have? 2 rows. And how many columns we have? Total 16 columns. So total how many characters we can display? 32 characters, the utmost. So if you want to display 32 characters at a time, you can able to use this 16 by 2 LCD. But you will ask me a question, sir, what if I want to display a sentence, a paragraph? Good, you can able to display, but you cannot able to display more than 32 characters. Then how I can able to display the paragraph? You can able to uh, shift this display to left or right. Okay, that means scrolling. So you can able to scroll the data in this display to left or right, so that we can able to display the additional information. So this is the controlling can be done with some type of commands. Okay, now you can able to see the 16 by 2 LCD is divided into, arranged in the form of rows and columns. We are having total 2 rows, row 0 and row 1, or you can call it as row 1 and row 2, and there are 16 columns. Okay, so this is the arrangement, and this 16 by 2 LCD consists of total 16 pins. We can able to see from the back side the representation. So 1 2 3 up to 16. So total 16 pins are there for the 16 by 2 LCD, and we are going to see what are the pin configuration of these 16 pins of this LCD. Okay, now let's start. Okay, the first two pins are nothing but your VSS and VDD, which is nothing but your ground and power supply. I'm sure if you take any device, if the device wants to work, it requires power supply, obviously, right? That's why the first two pins of nothing but your ground and power supply, where we can able to connect 5 volts to the VCC and ground to the ground pin. Okay, and the next third one is contrast adjustment. I'm sure you know the difference between brightness and contrast. So whenever if you take your remote, okay, there are some settings in your TV, okay, which is nothing but your display, right? And in the display where we can able to adjust the brightness and also adjust the contrast. So what is it contrast means? Contrast means it will adjust the colors inside the display. Okay, what is the brightness? So it will increase the actually the background brightness of the picture. Exactly. Here also, if you want to adjust the contrast of the characters of the data, okay, which you are displaying, you can use this pin. So which is nothing but your VE, that is a contrast pin. I will show you what is exactly it means. Okay, how we are going to use that contrast pin to change the contrast. Okay, next one, the next 4 5 6. Okay, 4 5 6 are nothing but your control pins. Okay, what is it control pins means? The fourth pin of your LCD display is register select, RS. We are calling it as RS, register select. And this register select, this pin is used to enable, okay, whether we are sending the comments or we are going to send the data from the 8051 microcontroller. So please understood this. We are using register select pin. Okay, this register select pin can able to tell the LCD display whether 8051 microcontroller is sending commands or data. So I told you, so whenever if you want to send the data, before that you will send the commands first. Okay, how you will send the command first? So how you will send the commands, in which lines? There are data lines. So we can able to see there are data pins for this LCD display, right? You are sending the commands in this data pin itself. So after sending the commands, you will send the data. Okay, now liquid crystal LCD display has inbuilt controller. Now controller has to know whether the microcontroller is sending the commands or data. So by which pin it is deciding? So based upon the register select. So whenever the RS pin is 0, that means we are receiving the commands. Okay, whenever RS is 1, that means we are receiving the data. So that is called data mode and command mode. That is called register select. Okay, next one is read or write pin. So you are wondered, sir, we are going to write the data so to the LCD, that's why we are using write pin. Then why we are using read mode? So is there any, it is possible to read the display? Yes, I told you LCD display has inbuilt controller, so that controller has some commands. Okay, suppose whenever if you want to know which command I have given, okay, previously, if I want to read that information, I can able to read that data with the help of this read mode. So I am sure you know that read and write bar, right, in your 8051 microcontroller. Similarly, your LCD display also have read write pin. Okay, so whenever RW is 0, actually this is RW bar, I have not represented here, it is actually RW bar. Now whenever if you whenever if you make RW bar is equals to 0, this is RW bar. Whenever if you make RW bar is equals to 0, and we can able to enter into the write mode. That means we can able to write the data into the 16:2 LCD. And whenever if R slash W bar is equals to 1, that means we are reading the data from the LCD. That means commands from the LCD. Okay. The next one is E. So sixth pin is nothing but your E, that is called enable. So whenever we are sending the data, okay, after sending the command, after sending the data, we are going to enable the display. So in order to enable or disable the display, we are using this command. This is called E command. That is E signal. That is called enable. So whenever if you want to make 1 0, that means clock high to low, okay, that means the display gets enabled. Then only we can able to see the data in the display. Okay, the next pins are simple, that is called data pins. Through this data pins, I am going to send the data from your 8051 microcontroller to the 16:2 LCD. Okay, the last two pins are nothing but LED positive and negative. Okay, I'm sure you know LED, right? So LED is called here backlight LED. So whenever if you take the Nokia mobiles, you know, small Nokia mobiles used in your earlier days, okay, during those days we can able to see there is a backlight. Whenever if you press the keys, we can able to observe there is a backlight for the keypads. Okay, similarly here also for this LCD there is a backlight. So if you want to turn on that backlight, you can enable this LED. So that means you can able to turn on this LED. If you don't want backlight, you can able to disable this LED. I mean, okay, in order to turn off the LED, we can able to do it. So this is the two pins which you need to turn on the backlight or turn off the backlights. So that is a backlight LED pins. Now I am going to show you one picture how to adjust the contrast. So I told you, right, there is a contrast adjustment. I am sure you know the contrast adjustment. That means the color of the text will be changed. I mean light or bright or medium, etc. So what I am going to do is, this is one microcontroller Arduino. Okay, I'm sure some of you know this Arduino microcontroller. It's just like your 8051 microcontroller with advanced features. Now here I have taken this example. I have found this picture from the internet, and you can able to observe there is a wiper that is called potentiometer. That potentiometer is connected to the third pin. Okay, by adjusting this potentiometer, I am varying the resistance, right? Whenever I am varying the resistance, you can able to observe there is a contrast is changing. Contrast means the text color, light, bright, medium, etc. So depends upon the requirement, you can able to adjust the contrast. Okay, this is I mean by contrast adjustment, right? And these are all 16 pins of this 16:2 LCD. Okay, so 16:2 LCD consists of commands. So I mean it will consist of inbuilt controller. So we are just going to send the commands and the data. Then the data will be displayed according to the commands received by this display. Okay, so let's start interfacing of this 16:2 LCD to your microcontroller. Before that, we are going to see what are the commands which we are going to use for the 16:2 LCD. Okay, now you can able to observe there is a LCD, okay, and which I have connected to your microcontroller somewhere, and I am displaying hello world. Okay, now you can able to see there is a something is blinking. So what is it blinking is called cursor. So this is called cursor. Okay, okay, so let's see the commands. So whatever the, if I send some commands to the 16:2 LCD from your microcontroller, so what will be the operation will be performed? Okay, whenever if I send 01H, that means it will clear entire display. So suppose now here it is hello world. Whenever if I send 01, so to the LCD from your microcontroller, it will clear entire display. Okay, next one is 02. If I send 02, return home. Return home means the cursor is here, so cursor will come to the home. Home position means the starting line of your LCD. Okay, next one 04. If I send 04, we are going to decrement the cursor. So decrement the cursor means we are shifting the cursor to left. Okay, next one increment the cursor, that means we are shifting the cursor to right. And shift display right. So I'm sure you know that scrolling display. Scrolling display means you can able to see in the railway stations or bus stations where the characters are scrolling in the display. So if you want to display more information with the help of scrolling thing, we can able to display characters. multiple characters at a time, right? So whenever if you want to shift the display right, okay, which is a command we are using 05. Whenever if you are whenever if you want to shift the entire data to the left, we can use the 07H. Okay, next one, whenever if I send 08H, that means display off, cursor off. That means we cannot able to see the data hello world in LCD display, and also we cannot able to see the cursor. Okay, this is the command. And 0A means display off, cursor on. So display will be off, only we can able to see the cursor. And the next one 0C, which is display on and cursor off. That means display will be on and cursor we cannot able to see. The next one is 0F, display on, cursor blinking. Now this is the 0F. So whenever if I write 0F, display on, cursor blinking, which is exactly which you are seeing in this picture, right? The display is on. That means display is on by showing the text hello world, and the cursor is blinking. Blinking means on and off, on and off. Okay, so this is a command which I have sent previously for this microcontroller, so that we can able to see the display as well as the cursor is blinking. Okay, so this is the command 0F. And the next one is 10. So 10 means shift cursor position to left. So we are going to shift the position of the cursor to left. Okay, so it will come to the D. So if you want to change that D, we can able to change the D to A or B, whatever you want. Okay, similarly you can able to shift the cursor position to right. Okay, and this is the command for that is 14. Next one is shift entire display to left. So we can able to shift the characters one by one. Okay, that is called one by one character shifting right or left. Okay, which is this command 05 and 07. And here the shift entire display, that means entire characters will be shifted to left. Okay, that is the meaning of this. So which is 08H and 1CH. So which is going to shift the display left, and which is going to shift the display right, entire display right. Okay, next one is 80. So 80 means force cursor to beginning, first line. So wherever if you want, wherever this cursor is in any position, you are forcing that cursor to the first line. So there is a two rows are there. One is this row, another one is next row. So whenever if I write 80, that means immediately the cursor will come to this position. Okay, now whenever if I write C0, the cursor will come to this position. Okay, the starting of the second line. So whenever if I write 80, the cursor will come to the first line of your LCD display. And whenever if I write C0, the cursor will come onto this second line, starting line of your display. Okay, so this is a thing. This is a sum of the commands. And the next one is last command is 38. So whenever if I write 38, we are going to select how many pixels we need to use for each and every character. Generally we are using 2 lines and 5x7 matrix. So 2 lines means I can have an option in order to display only on single row. Okay, only the top of the display. Even I can able to display only bottom of this display. That is another line, another option. If you want 2 lines, you can able to use this command. And we are going to use 5x8. Actually it is a 5x8 matrix. Okay, so whenever if you want to use how many pixels you want to display the characters, you can use this option. Now what is a 5x8 matrix? Okay, now you can able to observe there are 2 rows. Okay, now you can able to see the some shaded thing. Okay, the 2 rows and 16 columns. Okay, that is why the name it as 16x2, or someone will call it as 2x16, right? Now you can able to observe each and every character which is displaying in this date in the 16:2 LCD display based upon the pixels. For each and every character we are using how many pixels? 5 columns and 8 rows. That's why that is called 5x8 matrix. Okay, so you can able to decide whether I want to use how many pixels to display the character. So if you are using more pixels, you will get more clarity. So if you are using less pixels, there is a less clarity. I'm sure you know that, right? You know that HD, full HD, ultra HD, 4K, etc. Okay, so this is how we are going to display the characters in that 16:2 LCD display. Suppose if you want to display L, you can able to see there are pixels. For each and every pixel, we are representing the numbers. Okay, so this is the actual how to display any character here. Okay, now you will get some confusion. Actually, this not only these 17 commands, there are still hundreds of commands for this LCD display. Sir, you will question me, sir, how to remember all these commands? So whenever you want to play with the display, that means not in the exam, whenever if you want to play the display, when you are practicing with the LCD display, then you can able to take the data sheet of the 16 by 2 LCD display, and you can able to see what are the different commands to be followed. Okay, but as a exam point of view, you no need to remember all the commands, you no need to by heart all the commands, you just by heart only just a few commands like 4 to 5. That is enough for the exam purpose, exam point of view. Okay, whenever if you want to play with the LCD display, then you can able to use the data sheet of the LCD display, then you can able to see what is the command and what is the what is the operation it is going to be performed. Okay, so right now we are going to see only few commands among these. Okay, okay, my requirement is I want to display hello world. Okay, so hello world and display on cursor blinking. Now first, what are the different commands which I am using here? I told you that we are using only just a few lines here. Okay, few commands here. First one is clear display screen, which is nothing but your hexadecimal code is 01. So whenever if I send 01, the display will be cleared. And coming to the increment cursor, that means whenever each and every character is printing, so the cursor will be increment by 1 and it can able to display the next character. Okay, next one is display on cursor blinking. So display will be on and the cursor will be blinking like this. Okay, on and off. And force cursor to beginning the first line. That means whenever you are going to display any text first, the first command should be here, the force cursor to the first line. So wherever the position of this cursor earlier, come to the first line and start printing the text from the first line onwards. Okay, next we are using 2 lines and 5x8 matrix. Just now I told you, right? So we can able to use that option in order to display with more clarity. Okay, and we are going to see how to interface this 16 by 2 LCD display to your 8051 microcontroller. Okay, now you can able to see your 8051 microcontroller has ports. I'm sure whenever if you want to connect any input or output device to your microcontroller, you need to use ports, right? So that's why we are using the ports to connect the LCD display. Okay, and this is nothing but your output device. Okay, now you are going to connect these pins. I am told you there are total 16 pins are there. The first 2 pins are nothing but your VCC and ground. Okay, now I have connected ground and VCC to the first 2 pins, and the third pin is nothing but your contrast adjustment. It is optional. Okay, so whenever if you don't connect this whenever if you are not using this contrast pin, okay, simply make it to the ground so that we can able to display the dark text, okay, with more brightness. So if you want to make the character text to less brightness, you can able to use this contrast pin with the help of variable resistor. This is the variable resistor which I have used here, and you can able to connect this one. This is optional pin. So directly if you don't want to use, you can just directly connect to the ground. Okay, and the next one is read register select RS, which is connected to your port 2.0. Okay, next one is RW, which is read write pin, which is connected to 2.1, and enable pin, which is connected to 2.2 of your 8051 microcontroller. Remaining the 7, I mean sorry, D0 to D7, that is called total 8 data pins of your 7 segment LCD display. It is connected to the port 1. So port 1 consists of again 8 pins, bidirectional pins, and that 8 pins are connected to your data pins of your LCD display. And the last pin, last 2 pins are nothing but I told you there is a backlight. So you can able to see there is a green color background of this text, that is called backlight. So whenever if I connect positive to the VCC and ground the LED minus, then LED gets turned on, the backlight LED gets turned on, right? So this is how we are going to interface LCD display to your 8051 microcontroller. Okay, so before jumping into the program, so interfacing is simple. Interfacing is very simple. So just connect these pins of LCD display and connect to the microcontroller. So what is a big deal in that? But whenever if you try to write the program for this LCD, then it is a good. Okay, then you are great, right? So that's why we are going to see the program for this LCD display. Okay, the first point is, so whenever if you are writing the program, you will see the algorithm. So what is the first steps you need to do with the program? The first thing is you are going to send the commands. So what are the different commands I am using here? First I am selecting 2 rows and 5 cross 8 pixels. So before turning on the display, I need to select which display I need. I mean which resolution I need. Okay, so I need 2 rows and I am using 5 cross 8 pixels. That means 5 rows and 8 columns, right? Okay, 8 rows and 5 columns. Okay, next one, I am using display on and cursor blinking. So please remember what are the different codes available for these commands. Okay, we are going to see what are the different codes which I already seen, but still we are going to see what are the different commands we are using. Next, clear the display. Okay, clear the display and increment the cursor to right. So whenever if you are printing the text over here, hello world, H, next E, H, L, L, O, W. Okay, hello world. Like that we can able to increment the cursor to right. Okay, next one is your cursor home. So cursor home means row 1 and column 1. So I told you there are 2 rows. One is row 0, sorry, row 1 and row 2, and there is a columns called so column 1, column 2 up to column 16. So we are using the starting home position to print the text is row 1 and column 1. So we are going to print the text from this line onwards. That is your row 1 and column 1. Okay, now these are the steps which we are going to use the 16 by 2 LCD display. And all these, there are 2 different commands. One is actually we are going to have 2 different steps. One is the steps to send the command and steps to send the data. So at the end of the day, I need to display the data, right? So before that, I need to send the commands. Just now we have seen what are the different commands we have to do. Okay, first what we need to do is put the command on the port. So you will write the commands on the port 1, so which we have connected data pins to it, and make rs is equals to 0. So I told you whenever if I make rs is equals to 0, we are going to enter into the command mode. So during the command mode, we can able to send the commands to the LCD display. Next one, we are going to write the data. I mean, we are going to write the information, right? That's why there is a write, which is nothing but r/w bar is equals to 0. Next one, make latch enable. That is called your enable pin, where we need to make 1 to 0. So that like this. So we need to make 1, and next we need to make the pulse to 0. This is the thing we need to do in order to enable the display. And we are going to give some delay like 10 milliseconds mostly. So it is optional. So if you want to give, it is your requirement. Okay, it is optional. That's next thing is the next steps is steps to send the data. So just now we have sent the comments, and the next one is we are going to send the data. The same thing will be repeated, but except we are going to send the data here. So except here, rs is equals to 1. So rf is equals to 1 means it is enter into the data mode. So whenever rs is equals to 0, it will be entered in the command mode. Here rs is equals to 1, that means it is entered into the data mode. So we are going to put the data on the port. Similarly, make r/w bar is equals to 0, which is nothing but your write, and you make the enable pin to 1 and 0. That is your clock pulse will make to 1 and 0, and you will give some delay. Okay, so this is called your commands, and we are going to see the what are the different programming steps involved in this LCD display program. Now, I'm sure whenever if you want to display the hello world, you need to save that hello world somewhere. So you do not get it directly give the hello world text into the program, right? So where we are going to store that inside the memory location. So which memory location? ROM, permanent memory. So are this going to change? Hello world is going to change anytime. So it is fixed, right? So that's why I'm going to store the HELLO, and there is a space also there. Okay, and WORLD. Okay, sir, can I able to send directly H to the LCD? No, no way, right? So that's the way what I need to do. I need to convert that H to ASCII value. So each and every character, each and every special character or digit has ASCII value. That ASCII value will be stored inside the memory location, right? For H it is 72, for E it is 69, for L it is 76, etc., etc. For each and every character, even if you take, there is a space here. So for space also there is a ASCII character. So I mean ASCII value, that is your 32, and the remaining text also having different ASCII characters, which is stored inside your lookup table, inside your ROM location, right? So whenever if I store the lookup table data in the lookup table, I can use the DPTR, right? That's why I have initialized the value, so you can able to see the program starting line. So org starting line with address is 0400. Okay, and I have mentioned define byte. So define byte, I am sure you know there is a director, so assembler directives, right? You can able to use the assembler directive, disable db hello world, where H will be stored from the starting address location 0400, and the remaining characters will take the next address automatically. So which is the advantage of this directive define bit. Okay. Okay, I will share you the screen. I will share you on my screen, and you can able to see. We are going to see. I'm going to explain the program much easier. And what I am going to do is move dptr hash 4000. Why? Because I want to get the data from the lookup table from the starting location h, that is which is stored inside your 0400. That's why I need to initialize the dptr with value 0400. So that's why I have initialized the value dptr with 0400. Okay, now move a comma 38h. What is the 38h command? What is the 38h command here, which we have seen? 38h. First I am selecting the 2 lines and 5 cross 8 matrix. So just now we have seen, right? Select 2 cross 8 to 5 cross 8 and 2 rows matrix, right? So this is the command. So what is that command code? This is nothing but your 38. So that's why in the program I am giving move a comma 38h. Okay, now a call cmd. So a call means this is nothing but call instruction. So call instruction is calling cmd. So cmd means here it will come to program, will come to here. Move p1 comma a. So I told you there is some steps which is involved in the program. What is it steps? Put the command on the port and make rs is equals to 0, make rw is equals to 0, and make latch enable 1 to 0 and call the delay. So this is the steps we are going to follow first. So this is exactly which we are following here, right? I am putting the command. So command is present in the A. Why? Because I have moved that command 38 into the A register here, right? So A register command will be kept inside the port. And what I am doing, I am clearing P2.0. What is it? P2.0 RS pin. So RS pin is 0, which means RS is equals to 0 means it is entering into the command mode. So this is called command mode. And clear P2.1. So P2.1 is nothing but read write pin. So whenever if I make read write pin is equals to 0, what will happen? It is nothing but your write. So I am writing the data to the LCD display. You understood, right? Okay. Next, set B 2.2, clear 2.2. What I am doing, I am setting the 2.2 and clearing the 2.2. What is the 2.2 here? It is connected to enable pin. I told you, whenever if you want to enable the display, I need to make 1 and I need to make 0. So if I want to make 1, what is the instruction I am using? Set B. So set B means 2.2, and whenever if I want to make 0 again, I will use clear. So I am doing 1 here, I am giving 0. That means I am generating one clock pulse in order to enable the display. Now you understood, right? And call the delay. Okay, so delay means it will give you some delay. I told you here, this is that call the delay. So this is 10 milliseconds. So which is optional. It is up to you whether you can use the delay or not. Now write the return instruction. So return instruction will come to here, the next line. So a call means it will go to the command here and execute this instruction, come back to here. Again, the next line will indicate. So what is that next line? Move a comma 0f. So what is that 0f instruction? What is that 0f here? Display on cursor blinking, and you can able to see the step display on cursor blinking, the second step. So that step command has to be moved into the A register, again 0f, and the same cmd. That means it will execute the same thing. Okay, again it will come to the next instruction, it will go and it will give the next command, that is 01h. What is the 01h? Which is nothing but your clear display. You can able to see that clear display screen. Okay, display screen. So that is called 01h. You can able to see this program 01h is cleared the display. And move a comma 06h. What is it? 06h indicates increment the cursor, shift to right. So you can able to see the step. So increment the cursor to the right position. So I am incrementing the cursor and I am giving the data to the port. Okay, and it will execute the same instruction. It will come to the next instruction, that is called move a comma 0880h. What is it? 80h. So which is the last instruction. Cursor can come to the home position, that is called your first line of your row 1. Okay, so row 1 column 1, force cursor to beginning. So it will come back to the beginning starting location of your LCD display. Now we need to display the data. So what I am going to do, move R7 comma 0BH. Why 0BH? If you observe hello world, so I want to display H L L O O W O R L E. Where are this data? which is present in the lookup table. I want to fetch each and every data. First I will fetch this one, I will fetch this one, and I will fetch this one, and go on. How many increments I need to make? So 1 2 3 4 5 6 7 8 9 10 11. So what is it? 11 is called B in the hexadecimal number. A is 10, 11 is B. That's why what I am doing, I am making 0BH, which is loaded into the R7 register. So R7 register consists of now count. Okay, now what I am going to do is move R0, 00H. So why I am writing the 00H, I am going to tell you. Please wait for 1 second. So why I'm going to use this 00H, now you can able to see the next instruction, move A, 00H. Whenever if I want to get the first data, okay, here you can able to see the first data, which is present in the starting address of your lookup table, which is 0040. So if I add 00 to the 40H, that means I am getting this data. Say like, so R0 consists of 00. Now A register consists of 00 after the executing this instruction. Now move C A, DPTR. This is the magic instruction we need to apply in order to get the data from the lookup table. So A consists of 00, DPTR consists of 0400. If I add these two numbers, you will get 0400, which is exactly I need the H value, right? H value is 72. So the 72 will be come to the A register. Now A call data. So in this data, it will go to this instruction. I mean this go to the function move A, P1. So what is it? P1? P1 now consists of 72. So whenever the P1 consists of 72, immediately it will display H. Okay. So again, you need to follow some steps, right? The same steps. So put the data on the port and make RS is equals to 1. So earlier we have make RS is equals to 0 for the command. In here instead, here we need to make RS is equals to 1. And read write pin is equals to 0, enable latch and call the delay. Exactly what we have done in the previous step. The same step has to be repeated except RS is equals to 1. So which is exactly we have done here. So we can able to see set P 2.0 where we are setting the RS is equals to 1 and clearing the P 2.1. That means R/W bar is equals to 0. And I am enabling the E value. That means making the clock pulse to high to low. And I am calling the delay. So again, it will come to this instruction. What is the value of R0? 0, 0. Okay. And it will decrement the R0, R7. So earlier R0 it will consist of 11. So 0B. Now it consists of 0A. That means 10. So what is the 10 value? So it can able to get this value from the next line onwards. That means your E value will get. Okay. Similarly, for each and every decrement, it can able to keep on getting this data, and it is displaying in the 7-segment display. So finally, we can able to see the 7-segment display over there. Okay. So this is the end of this session. So if you are having any doubts, you can able to ask me if you are having any doubts in this program. Okay. So that's it for today's class. Hope you enjoyed this video. Thanks for joining.